Hi, welcome to part 2 of compound probability. In the last video, we made an outcome chart to show the probability of flipping a heads and rolling a 1. And we got that the probability is 1/12. Well, there's another way you can show the sample space for a compound probability problem. The sample space, remember, is all of the possible outcomes. So this is the sample space using an outcome chart. The other way we can show the sample space is a tree diagram. So let's do a tree diagram for the same problem. Let's find the probability of flipping a heads and getting a 1. And I know you know that's 1/12, but we want to confirm that with our tree diagram. Okay, so a tree diagram has branches like a tree. Each set of branches represents one of the experiments in the compound situation. So the first set of branches in this is going to represent the coin flip. We're starting at a single point, and my tree is branching out. It's kind of an upside down tree. It's branching out to the two outcomes, heads and tails. Got two outcomes here for that coin flip. I'm just going to label over here that this is the coin flip. Okay, now let's think. If we flip a heads, what are the possibilities for the number cube? There are 6 of them. So branching out from the heads option, the heads route, are going to be 6 branches. And here's a tip when you're making a tree diagram. Write the outcomes first, and then make branches going to them. Because otherwise, it's really easy to get all bunched up, and then it gets messy. Okay, so if you flip the heads, for your number cube, you could get a 1, 2, 3, 4, 5, and 6. And so each one of these branches represents an outcome. This branch is the outcome that's representing getting a heads and a 1. This branch is representing getting a heads and a 2. This is representing getting a heads and a 3, and so on. We're not done yet, because you could also flip a tails for that first coin flip. So if you flip a tails, what are the possibilities? They're the same as with the heads. You've got 6 different outcomes. So write those outcomes in, and draw the branches. All right, and now how do we know how many total outcomes there are? Well, to find the total outcomes, we just need to count the number of branches, complete branches. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 total outcomes. And then which outcome represents a heads and a 1? Let's circle it. This outcome, this branch, is a heads and a 1. So there's only 1 out of the 12, and the probability is 1/12. These two diagrams show the same thing. And for a problem with 2 events, you can pick which one you like better. But now I want you to think for a second. What if you have to find the probability of 3 events? For example, what if I asked you to find the probability of getting heads 3 times in a row? Would an outcome chart work for this? The answer is no. You have to make a tree diagram. And you'll see that as you continue your work. All right, good luck.